Okay, let's take a look at this problem here. Um, First thing we need to notice is that the graph is f of x down here, and they've given us a statement that g of x is equal to the integral from 5 to x of f, and this is in terms of t. So first thing I look at is they're asking us to find g of 3. Well, g is equal to all this integral business, and so what they're asking us to do is find from 5 to 3 of the function. So first thing we look at, this is just the area under the curve, but notice that the from 3 to 5, so from this point here to this point here, we're looking for this area underneath this curve. So we're looking for all this area right in here. Well, you have to remember that we have to do what? Since the limits of integration are backwards, we can flip them over, but we have to make it negative. So we're going to go from 3 to 5 and of this function value, or the area under the curve. So we just have to calculate this area. I look at it and I see that it looks like a rectangle of 2 units and then a triangle up here. So it looks like this is equal to positive 3, but since we're flipping it, it's going to be negative 3. So hopefully that makes sense. Just to reiterate, you have these two squares here, and you have a little triangle right here. Its length is 2, and its height is 1. So half of 2 times 1 is 1. So there we are. You have a negative 3. All right. The next statement says find g prime of x. Well, this is g of x, and so g prime of x, this is the second fundamental theorem of calculus here. So since this is just a single x, g prime of x, take the derivative of both sides, we have what? G prime of x is equal to the derivative of the integral from 5 to x of this. So hopefully you recall that when you're taking the derivative, in this case, all you have to do is replace the t with the variable x. So once you see that, this is a pretty easy problem. So the derivative g is equal to f of x, which we have graphed. So what is the value g prime of 3? Well, what is f of 3? F of 3 is up 1. It's just a function value here with 1. Well, the second derivative, if the first derivative of g is equal to f of x, the second derivative certainly would be what? F prime of x. So how do we figure out the second derivative given that we know only f of x? Well, we just look at the slope. The slope at 3, it looks like it's on a straight line here, right? So we're just looking for rise over run. So the slope here is up 1 over 2. So that is 1/2. Okay. Moving on, where is g decreasing? Well, g decreasing, how do I figure that out? I have to take the derivative of g, and I need to look in to see where it's less than 0 or where it's negative. Well, since f of x is equal to g prime of x, all I have to do is look and see where the graph is below the x-axis for f. So it looks like it happens, let's change colors here. It happens between 0 and 1 for x, and it's also negative between 6 and 8. 6 and 8. Okay? where is g concave down? When I see concave down, I immediately think of the second derivative. And since it's concave down, it's where the second derivative is negative. And if we know that f of x is equal to g prime of x, then the second derivative of g is equal to the first derivative of f. So when is the slope of this blue function over here, when is it negative? Well, the slopes are positive here, and it looks like it's only negative when I turn the corner here between 5 and looks like 7. So it's concave down on the interval from 5 to 7. Okay, so this is a nice problem, and it all stems on the fact that you understand that the integral means area under the curve, and also that this is a problem where you have to understand what the second fundamental theorem of calculus involves. Okay, so I'll pause the video here, and there's a couple more questions relating to this graph. So I'll see you on the other side.